the last type of thing I'm going to look at here with the polynomials is this specific type of question. Is how do I create new polynomials using the roots of another polynomial? And the idea is this. If I know alpha, beta, gamma, etc. are the roots of one polynomial, and I want to create a new polynomial which has roots, say the reciprocals of those. Okay, so 1 on alpha, 1 on beta, 1 on gamma. What you basically do is let a pronumeral, I often make it y, it doesn't have to be, it could be any pronumeral really, but I make it look like the root that I'm trying to create, where x takes the place of the root of the original one. So these are the reciprocals, so it's 1 over. So I'll let y equal 1 over x. But then I'll go and make x the subject and substitute it back into the original polynomial. Rearrange that, and that'll create this new polynomial that I look for. So if it was reciprocals, I'd let y equal 1 on x. If it was some constant times each root, then I'd let y equal some constant times x. Say I wanted the roots to be the old root plus some constant number. Then I'd let y equal x plus some constant number. If I wanted a new equation where it was the root squared, then I'll let y equal x squared. So basically we just let y equal, and I'll make x, I'll place x where the root was. And then rearrange it and sub it in. So let's have a look at some examples so I can show you what I mean. So the original equation, x cubed plus x plus 2 equals 0. Alpha, beta, and gamma are the original roots. We want to find an equation who are the reciprocals. Okay. So I'll let y equal 1 on x, which means x equals 1 on y. And then I'll go and substitute it back into the original equation. And I get a new equation. Now, of course, that's not a polynomial. So I need to make it a polynomial. So I'll multiply everything by y cubed, and I get 1 plus y squared plus 2y cubed is equal to 0. And what we would find is that the solutions to this first equation, x cubed plus x plus 2, would be the reciprocals of the solutions to this new equation. Okay. Now, why does that come in handy? I suppose it comes in handy is, say I wanted to find the sum of 1 on alpha plus 1 on beta plus 1 on gamma. Now we have a technique where we can create an algebraic fraction and do it that way. But what I now could do is say, well, hang on, I'll use this new equation and say, well, that'll just be the sum of the roots of this new equation, because this new equation has roots, 1 on alpha, 1 on beta, 1 on gamma. Let's try it with alpha plus 1, beta plus 1, gamma plus 1. So I'll let y equal x plus 1, rearrange it, x is y minus 1, substitute it into the original polynomial. Expand out, collect like terms, there's my new polynomial. This one's an interesting one. Alpha squared, beta squared, gamma squared. So I'll let y equal x squared, so x will equal y to the power of a half. Substitute that one in. Now, of course, that's not a polynomial because we don't have fractional powers in polynomials. I need to make those integers. Now, in order to do that, I need to move terms. And what I do is everything that has a fractional power, I place on one side of the equation. Everything that doesn't have a fractional power, I'll put on the other side. Now, 2 is the only thing that doesn't have a fractional power, so I've moved that to the right-hand side. I've also factorised as well. So everything with a fractional power is on the left-hand side. So now I'm going to square both sides to get rid of the power of a half. And I'll get y plus 1 squared equals 4. And now I should be okay. Everything will have integer powers. If I expand that out, bring the 4 back over, I've now got a polynomial. And that polynomial would have roots, alpha squared, beta squared, gamma squared. So before you square both sides, you need to separate, because otherwise, if I didn't separate, remember when you square, you get twice the product, how you get the 2ab. So if I leave the 2 there, when I multiply the 2ab, I'm still going to have a half as a power there. So I don't solve the problem. So we need to separate first. Ooh, 1 on alpha squared, 1 on beta squared, 1 on gamma squared. Well, same idea. We'll let y equal 1 on x squared. So now x would be y to the power of negative a half when I make x the subject. Substitute that in. Now not only do I have fractional powers, I've got negative powers as well, but I'll still do the same idea. Anything that has a fractional power, I'll put to one side. Anything else that doesn't. I factorised, but remember when you factorise, you always take out the smallest power. Minus 3 on 2 is smaller than minus a half. So I factorise out y to the minus 3 on 2, leaving me with y plus 1. The negative, well, how do I get rid of the negative? Well, negative power just means I'm on the bottom of the fraction. And to get rid of fractions in equations, multiply. So now on the other side, we get y to the power of positive 3 on 2. All right, still got a fractional power though. I've still got that 3 on 2. So now I'll square both sides. And we get y plus 1 squared is 4y cubed. Beautiful. Now everything will have an integer power. We should be okay. Expand out. There's an equation. As I say, it now has an advantage for questions like this. Alpha squared plus beta squared plus gamma squared. It's just, I guess, another way of approaching the problem. Okay? The traditional way we would have done it is to go back to the original equation and said, oh, well, I know that the sum of the roots squared will be the sum of the roots 1 at a time squared minus 2 times the sum of the roots. All right. So we could just substitute in and we get negative 2. But having created our new equation, that equation we found back in C, remember the equation in C we said has the roots alpha squared, beta squared, gamma squared. It'll just be the sum of the roots of that new equation minus b on a, which is minus 2. I'm not saying that you do that. Like if they haven't asked you to find that equation, I'm not suggesting that that's the quickest way of finding it. But had you already found that equation and they asked you to find alpha squared plus beta, that's certainly quicker to use the new equation. All right, so let's play around with these new equations, creating new equations. So some questions out of Cambridge and some Patel ones as well.